This time, Mike and Mike will be performing the EVA. Bueno will be riding the robotic arm, and Massimino will be the free float crew member. Their first work site is the SOAP, or the Small ORU Protective Enclosure. This is where the rate sensor units are flown up. The item that you see flashing there is the pick stick that I just showed you a moment ago. So the first thing they're going to do is retrieve that pick stick, and then they're going to open up the SOAP and retrieve one of the 3 new RSUs. And you can see Bueno doing that now from the robotic arm. Once the first RSU is retrieved, they'll close the lid, and then they'll start into the opening of the aft shroud doors. The item that you see flashing on the left and then now on the right are the fixed head star tracker light seals. Those need to be retracted prior to the opening of the aft shroud doors. Once the doors are open, the horizontal bar that you see there is the cache, or the cross aft shroud harness. It's simply a harness that routes power from one side of the telescope to the other one. The crew will have to relocate this down towards the bottom of the aft shroud in order to allow for the installation of the foot restraint that you see flashing now. This foot restraint is for access of Mike Massimino inside of the aft shroud. And together the crew will be performing the swap of the first RSU, which is up in the upper right-hand corner that you see there. This is RSU number 2. The person that you see in the middle is Mike Massimino. In the upper right-hand corner of the video is Mike Good feeding the new RSU into the worksite using the pick stick. The RSUs are installed using 3 bolts and 2 electrical connectors. Once the new RSU is seated, Massimino will egress the foot restraint, and then he'll stow the old RSU back in the enclosure where the new one launched in. At this point, Mike Good will retrieve the new RSU, the second of 3 new RSUs, and this one will go into position 3, which is in the upper left-hand corner. This change out of this RSU will happen very similarly to that of the previous one. The remaining RSU is the one in the middle, which is RSU 1, and Mike Good will do this one and access this one by himself, positioned as you see there in the video. Again, all of them have 3 bolts and 2 electrical connectors. Once all the RSUs are swapped out, the crew will relocate the cache back up to its original location, and then close the aft shroud doors. And these doors are a little different than the other 2 sets of doors. So we have 2 crew members timeline to assist with the door closing. The right door is actually larger than the left door, which makes it more flexible and then therefore more difficult to engage. Once the doors are closed, the crew will begin with the change out of the second of 2 batteries. The battery flashing down in the payload bay is the one that Mike Massimino will be working on. Again, he'll open up the thermal cover and release all of the bolts on the new battery. Mike Good will be on the robotic arm up at bay 2 at the telescope, and he will retrieve the old battery. Again, 14 bolts and 6 electrical connectors along the bottom. Megan will then fly him down to the payload bay, and the crew will once again do their battery swap activities. So Massimino will hand up the new battery to Bueno, and then Bueno will hand down the old battery to Massimino to put away back onto the carrier. Once Bueno has the new battery, Megan will fly him back up to the Bay 2 battery door, and he'll perform the installation activities. And we have some video showing the NBL training for this. There are some guides on the 4 corners assisting with the installation of the battery, and then you can see the bolts around the edges, and there's some down the middle, and then the electrical connectors are located along the bottom of the battery. And this is footage of Bueno driving one of the center bolts for the installation of the new battery. Once the installation is complete, he'll close out that bay door, and then the crew will perform their usual cleanup activities in the payload bay, and then they'll ingress, come back inside, and that'll be the end of EVA2. At this point, I want to take some time and explain in more detail some of the ACS tasks, some of the ACS tools that we'll be using. I think this will help everyone understand the video that they'll be seeing later on. So I want to begin with, again, the summary of the ACS task is that the crew will have to remove 4 of the electronics cards that are inside of the instrument. And in order to do that, they'll have to remove a cover plate, which is similar to this. There are a total of 32 non-captive fasteners on this cover plate, and the total of 36 that I've mentioned before includes 2 additional fasteners on either side of the card, and these will be used to install some guide studs, which will then be used to install some additional tools during the task. One thing, though, is that over this cover plate, of course, is a grid. So we need to remove that grid in order to just get access to that cover plate. What the crew is going to do is they're going to use this grid cutter. Each one of these legs has a bolt associated with it and also has a blade. As the crew drives the bolt, the blade will come down and then shear one of those legs on that grid. At the same time, it will also trap and control the grid so that we don't have a sharp edge hazard. So once this has been removed, then the crew will actually have the access to this black cover plate, and they can begin releasing all of the fasteners. Now, because of the visibility and the access to this work site, which is really tight up in the right-hand corner of the instrument, we are initially breaking the torque on all of the fasteners using a manual tool. This will ensure that when we come back with the power tool, that we don't strip out any of the heads of the fasteners. Once all of the fasteners have been released, the crew will be installing this item, which is the fastener capture plate for the ACS task. Now, this lines up with all of the holes on the black cover plate. You can see that there are numbers on all of these, and so there's a total of 32 fasteners that will be released. This cover plate is specifically designed so that the holes are large enough so that the bit from the drill can come in and release it. However, they're also small enough that once the fasteners are all released, they don't come floating out. So once everything is released, this cover plate will be attached to this black plate. The fastener capture plate will be attached to the cover plate. This whole thing will come off as one unit, and then the crew will have access to all of the cards. During the removal of the cover plate, depending on the location of the fasteners, the crew will have either better access or worse access. So some of them will be fully released, again, using the manual tool. And some of them will be released using this item, which is the mini power tool. This tool was specifically built for the STS and ACS tasks. It's a high RPM, a low torque power tool. It has an LED array on the tip that provides additional illumination to the work site. And then again, as I mentioned, it's a high RPM but low torque. So now that all the fasteners have been released, then the crew has access to all 4 of the cards. And at this point, the crew will then use this item, which is the card extraction tool. Their indexes, you can see that there's a spot for each of the 4 cards, and by rotating this lever, the crew will be able to move this jaw from one position to the next. These are the jaws that the crew will use to clamp on to the card, and then by driving this additional bolt, it will actually extend some elevator blocks that will pull the card out from the current location where it's at. This will be repeated, of course, for all 4 of the cards, and as the cards come out, they will each be going into an enclosure to control them.